look at this together. All right, here we go. Okay, last lesson of the year. What? 561 triangle congruence. So to start off first, I want to just talk about congruence, because what's the difference between congruence and equality? Equality, for instance, here we go. Right? If I have AB right here, equality is saying that AB is equal to AB. There's no other AB in the world. It doesn't exist anywhere else. AB is just this, right? Now, I can say, though, that AB is congruent to CD. And what that says is they are the same length. It's just in a different position. Congruence allows you to have the exact same thing, but just in a different position. It's slightly different, just a slight difference between those two. So when we're talking about congruence, we're talking about two different triangles, and there's some things that are the same between them, which then allows us to say that the triangles are congruent, right? They're the same triangles, it's just put in a different location, okay? Think of like baseball fields. What's the same about baseball fields? I mean, what's the same? They all have 4 bases. Are the bases, some bases closer to each other than others, or about all, like Major League Baseball? Is it going to be the same distance from first base to second, second to third in all the stadiums? No? Maybe you're thinking like about the home run wall is different. Different stadiums have home run walls that are further or closer. But the distance between first and second, second, third, home plate, those are all exactly the same, 60 feet or 90 feet. I can't remember which one it is. So what you can say is, the sides of the fields of a baseball stadium are congruent. So we could say that, all of the infields of all the stadiums in the United States, they're all the same. Or actually in the world. I mean, it's pretty uniform. Okay. So we're going to show triangle congruence using sides and or angles. And here's our congruent symbol. Okay, that's our congruent symbol. Whoops, you guys can't see that. So the thing to know is anytime you see an S, and S is talking about sides. Anytime you see angle, angle is talking about, or A, angle, S, sides, just real connected, real easy. And we could see that these two triangles are congruent. And how can we see that? Through the argument of side, side, side. So if these sides are congruent, they're the same. Those sides are congruent, they're the same. Those sides are congruent, they're the same. Then the two triangles have to be congruent. They have to be the same because the parts are the same. Okay. Now the parts, which parts are the same is what is important with this lesson. So this one is congruent by SSS. Okay. But we have different options, and we're going to have to just start to recognize the pattern. And the key is to look at the position of the tick mark, showing that these are the same. 2 tick marks aligns with 2, 3 with 3, and so on like that. Okay. So let's look at the 3 that we have to really get through. SSS, SAS, and what does that have? First, I didn't really mark the angle, in the same way that the angles are marked congruent here. We can mark it with 2 tick marks, 1 tick mark. But with this, we have to bring in a new definition here, a new idea, and that's vertical angles. Vertical angles, I think of as like, like the X-Men, kind of like a badge on their chest. The X-Men, and these kind of make V's as well. Actually, I should have done it the other way around. It reminds me too of like a nuclear kind of like warning symbol. Kind of like that. I don't know if that's the exact same symbol, but it kind of makes a V, right? You can think of it like that. And all it's saying is that opposite sides of a intersecting lines are always going to be the same. So like think of like scissors. When you open the scissors this far, does the blade open like much further? No. And if it didn't work that way, scissors, you wouldn't know how to use them because you'd be like, well, how far do I have to open it? Do I have to open it this far? Where you could see that if I open it up this far, over there, it's opening up that far, right? So that's how you know how to use scissors. It might be like, well, obviously, right? But we can use that obvious idea that the opening here is the same as the opening over here. The opening here is the same as the opening over here. And that is really talking about vertical angles. Okay, so any two lines that intersect are always going to make vertical angles. There's Philemon. All right, let's get him in here real quick. And that's kind of like the key to, if you're missing information, it might be that you just have to recognize that, oh, you have a vertical angle, so you can count it. So we can count these as congruent. So look what we have here. Sides, angles, side. You always read it that way. Essentially, you're looking at one of the triangles, and that has the recipe. Side, angle, side. Because the other triangle has what? Side, angle, side. These two are the same. The angles are the same because of vertical angles. The two sides here are the same. So this is congruence through side, angle, side. It's always relating the two triangles. If they're touching or they're separate, it does not matter. But here we have side, angle, side as our postulate for proving that these are congruent. Okay. So far, so good. I mean, it's basically just pattern recognition, right? I'm just teaching you the three patterns. Okay, so that was SAS. This is congruent by SAS. Here's the last one. And I forgot about this one, so it's in the very corner. But it's just a pattern, right? Just a pattern. Angle, side, angle. The tick marks here showing these angles are the same. The side in between it, and it's important for that. If it's ASA, that means the side is in between two angles. It's in between the two angles that we are seeing that are congruent. And thus we have angle, side, angle. Those are congruent. That's it. Okay. So let's look at some examples, and we'll see how we're feeling about it. So far, so good. Thumbs up, sideways, down in here. Thumbs up, sideways, down. Yeah. Okay, good, good. Let's see if y'all can do this. I'm going to ask you to tell your partner, the person next to you, what you think about this. Which one is this one going to be? All right, so tell your neighbor behind you, just real quick, like a 1 second check-in. Which one is this one going to be? Nice, Calvin? I don't see any tick marks for angles, though. So you can't ever don't look at it and say it looks the same. We're never going to go on how it looks. Only go on the tick marks. Good, Kim. Good, Kimberly. I heard it over here. But Hector, there's no angles. There's no angles. There's no angles that are congruent. True. So I just look at the tick marks. Yeah. So No. We'll have some examples where it's not, I believe, here. It's connected, like for instance, this one's connected, but we're still looking at them as separate triangles. Okay. Even if they're touching, it doesn't matter. We're just looking at it as this triangle compared to this triangle. So that's good. I heard a lot of people in here, SSS, side, side, side. And I first just look at the tick marks and say, well, there's no indicators that the angles are congruent at all. So it must depend on the sides. And SSS, boom. All right, let's go over to this one. This one has that one aspect that we got to keep in mind. So go ahead and tell your neighbor on this one. What do you think this one is? What do you think this one is? And at home, you could just put in the chat. Yeah, nice Fatih, nice Kim, nice Ava, nice Hector, nice Marco, and I'm guessing we're Jatavia, perfect. We're good in here too. What do we have? Side? What? Angle, side. These two angles, what do we call those again? Vertical angles. Vertical, they're across from each other. Perfect, guys, perfect. Oh, side angle, side, with vertical angles. Good. All right, how about this one? How about this one? What's that one about? That was a little trickier. But remember, we just got to notice the fluorescent one there. Those are congruent. Nice. Kim, close. Close. Yeah. Yes, Kimberly. And sometimes you just mix the letters up, right? So somebody said SAS, and then they saw that they just kind of like misidentified it there. Because what do we have here? Angle, side, angle. These angles are the same. So again, remember, we are pointing out what is congruent between this triangle and this triangle. We know that we have two angles, we have two sides, and we have two angles. So it's angle, side, angle. So again, the classification is just what is in common between one and the other triangle. That's the only way we're doing classification. And what do we get? ASA. Boom. All right, this is the one where like you have to think about it a little bit because there's one part here that is slightly different than what we've seen so far. So think about it for a second, then tell your neighbor. How about this one? What kind of relationship do they have? I will say in the homework, it does give you options that say there's no congruence. So I guess it could be this, but maybe not. Okay, so Marco, there's no SS, but you're on the right track. All right, anybody ever lived in an apartment? I've lived in apartments, yeah. So one thing that's not great about apartments is you share walls. You share walls, right? So if your living room is the same wall as someone else's living room, and they're watching TV at 2 a.m., then you're watching TV at 2 a.m., right? And that's why it's hard to live in an apartment sometimes if you like quiet. But is your wall to the living room technically the same wall as their wall to the living room if your apartments are butted up? Think about that. If your apartments are butted up, the wall that is in common between them, like this wall right here, on the other side is Mr. Halpine's class. But that wall is the same wall from both perspectives, right? That wall, from our perspective, it's this wall. From the other side, it's the same wall, it's just from the other side, right? So think about this. This is the wall that's shared between two apartments. And that wall is exactly the same. I don't want to put it because it'll like ruin it for the other classes, but if I did, I'd put it like this, and I would say that this wall is the same for both of them. You see what I was saying with this now? I think my analogy went kind of sideways, but all I was saying is, if this is the wall between two apartments, it's the same wall for both apartments. So when we say that, we know essentially what we're looking at is it the same length? And we could say, yes, it is the same. It's kind of like reflective property. 1 is equal to 1. It's that kind of basic idea. So yes, this one is side, side, side. And you had to see that. So in the homework, don't get confused on that. That wall is the same for both. Okay. Yeah. Uh-huh. Yeah, if there's no indicators on angles, and you can't assume it. You can't say, well, this looks like that. You can't say it looks like it. It would have to have a tick mark showing that it is. You can only trust the tick marks. Okay. Good question. Last one. This has a bit of everything in it. What's that? Anyone at home? Good, Kim. Good, Marco. Yep. What else we got? Okay, so this is another apartment situation. Apartment situation, because what? That's the same wall, right? So I'm going to put this back here. And I put 3 tick marks, not necessary, but I put it there. So what we have is what? This angle and that angle. This side and the same side, because it's the same wall. This angle and this angle. Angle, side, angle. Okay. You see how it's pretty quick to match these? Okay. And this really is, it's the last lesson for the unit, and it's also just introducing this. For next year, you will go further into it, and today is mainly about identifying it. Now, some of the homework is going to ask you, okay, well, they gave you all the information except for the one that had 3, and what else, or except for the one that had the 1. And what else did you need to add to make it into side, side, side? You had to add another side. Okay, so some of the assignment is going that direction. It says, what do you need to prove that it's SSS? What do you need to prove that it's SAS? But honestly, I gave you 18 problems for homework, and it's doable in the 20 minutes we have in this class easily. Okay, so I'm giving you extra time to work on this today. At home, let me know on a scale from 1 to 5. How you feeling? How you guys feeling here? 5s, 4s, 5s, thumbs? Good. Yeah, that's fine. Keep your thumb. Okay. All right, good. That was about 15 minutes. 4.6. 4 fours, fours, fours. Once you see the homework, you'll see it's great, Fafi. Good. All right, you'll see that it's very doable.